Hello dear students, I am Professor Mandar Dikshit from Electrical Engineering Department. Today we will solve a problem based on calculation of RMS value of an alternating quantity. The problem which I have taken states that find the RMS value of the waveform shown in the following diagram. The diagram is open to you. By observing the waveform, we look that the waveform is a triangular waveform, that is, it is a non-sinusoidal waveform. Also, if you observe, the waveform has one positive peak and in negative peak or negative half, the value is 0. Again, it will go in positive half with increased value and in negative half, it goes to 0. Hence, the waveform is unsymmetrical. That means its positive half is not equal to negative half, or both halves are not symmetrical. Hence, this waveform can be considered as unsymmetrical waveform. Now, the RMS value of an unsymmetrical waveform can be calculated considering full cycle. So, in our waveform, the full cycle starts from 0 and finishes at 4 seconds. From 0 to 4, the waveform is completing its full cycle. Hence, RMS value will be calculated over this full cycle period. The time interval for full cycle is 0 to 4 seconds. As the waveform is unsymmetrical, it has two parts. 0 to 2, the waveform shape is different, and 2 to 4, the waveform shape is different. Hence, we will divide the full cycle into two intervals. The first interval will be 0 to 2 and second interval will be 2 to 4. Let us write down the value of current corresponding to this interval. So, first interval is 0 to t to 2 seconds. From 0 to 2, the waveform is traveling as a triangle waveform. Hence, the value of current at this waveform can be calculated as slope of the waveform. The slope can be calculated as x coordinate and y coordinate. So, slope will be y coordinate, that is 20, divided by x coordinate is 2, that is 20 by 2t. So, my current will have a slope value of 10t. The second interval will be 2 to 4, that is 2 seconds to 4 seconds. Hence, for second interval, the corresponding value of current is 0 as the waveform is having no wave shape. So, I will be equal to 0. Hence, we have two equations of current for two intervals. First is I is equal to 10t and second is I is equal to 0. Now, let us calculate the value of RMS value by substituting these intervals. Hence, IRMS can be calculated as square root of area of squared wave divided by base length of full squared wave. From our waveform, we can write as area of full squared wave can be determined as integration with a period of 0 to 4 seconds. The equation will be I square squared wave with corresponding parameter of integration t divided by base length of full squared wave. The full square wave completes one cycle in 4 seconds, hence divided by 4. Just simplify, so squaring both terms, we will get I square RMS is equal to 1 by 4 integration 0 to 4 I square dt. Now let us substitute the splitting intervals in this equation. The first interval is The first interval is 0 to 2 and second interval is 2 to 4 I square t. Let us put the equations of intervals. For first interval, equation is 10t square into dt plus. For second interval, we have value of current as 0. Again simplifying, we will get as second part is 0, we will neglect it. So hence IRMS square is equal to 1 by 4 integration 0 to 2 10t square dt. So solve this further. 10 square will take outside, 10 square divided by 4 and integrate t square. The integration of t square is t cube divided by 3 with interval of 0 to t. Let us substitute the intervals. First is 2 cube ten square can be 100 divided by 4 into 2 cube is 8 divided by 3. If you solve this, I'll get IRMS square is equal to 66.66, and if you take square root of both sides, I'll get IRMS is equal to 8.16 ampere, which is answer of our problem. Hence, the RMS value of our given waveform is equal to 8.16 ampere. Thank you for watching this video.